Handmade homework. There are a few homework assignments on WebAssign. Let's see. It's 2, 6, 2, 7, 3, 1, 3, 2, 3, 3, and 3, 4. Okay, it's due on the Friday after spring break. So not this Friday or next Friday, but the following Friday, the 1st. Okay, and we finished notes for 3.4, the chain rule. Okay. All right, 3.5 is implicit differentiation.
We did 3.4 yesterday, right?
Yeah. And then differentiation. Yes, and then yesterday when we did 3.4, it was learning how to use the chain rule. And for implicit differentiation, we are also going to be applying the chain rule. Okay, we've got a function y, and y is a function of x. So let y be a function. Okay. When we differentiate y, we're going to apply the chain rule and multiply y with its derivative, y prime. Okay, it seems right. I'm like, is it the chain rule? I think it would be the chain rule. We're going to practice. Okay. So we differentiate y, and then we apply the chain rule and multiply by y prime, which is the derivative of y with respect to x, or you can write it as f prime of x. Okay, cool. Yeah, it looks good. So not only are we practicing using the chain rule in a sense, but we're also doing implicit differentiation. So first example. Take the derivative with respect to x. Of some function f of x, and it's cubed. Okay, so this would be first doing the power rule, bring the 3 down, have f of x with f of x squared after that. And then chain rule here, multiply by the derivative of the inner function, which would be f prime of x.
So technically, you do like the first part. I think like you do like the derivative of the entire like fx over 3, and then you do another derivative of just fx, right?
Yeah,
Something like that.
yeah.
Okay, yeah.
And then you could also write this as, let's say y equals f of x. It's 3 times y squared multiplied with y prime. Okay, we're taking the derivative with respect to x of sine of some function f of x. Okay, so with the chain rule, you take the derivative of the outer function, which is sine of x. The derivative of sine is cosine. So you have a first
And
start.
then you do, and then after that you do, and then after that you do fx, right?
Yeah, take the derivative of that and multiply all of it together. So we got a cosine of x times outer function, inner function. Where we're going to write this as cosine of y times y prime. Next one.
Wait, fx equals, wait, fx is the same thing as y, right?
Yeah.
Okay.
Derivative with respect to x. Of e to some power that is a function. So e to the f of x. So derivative for e to its power is e to that same power. And then apply the chain rule. Multiply by the derivative of the inner function, which is that power, f of x. So multiply with f prime of x. And then we can also write this as e to the y times y prime.
Wait, wait, how did you end up with E equals, how did you end up with the EFX and then FX derivative? Where did the FX derivative come from?
That's from the chain rule. So like your derivative of your outer function is like this part, and then multiply by the derivative of the inner function, which is actually up here.
Okay, so even though it's a power, it ends up becoming like,
Yeah, even though it's up in the power, it's still where your inputs go, or where your function, where your inner function is. I don't know. So we're going
so
to
even
go,
though the power just ends up becoming, it still ends up like applying like exponential power or something.
yeah, it's, I'll write it right over here. So when you have your, let's see, just derivative of e to the x, just plain x, you get e to the x. But the difference with this is instead of just x, there's a function of x. Like maybe it's a polynomial or something. So you have to take the derivative of the outer function, which is copy it down just as it is. With its, copy this input too, copied here. And then use the chain rule, multiply by that derivative of the inner function of this. We're going to go through how to use implicit differentiation to solve an equation. That's my good steps. Okay, first step, take the derivative of both sides of the equation. With respect to x, or with respect to whatever variable you have. Okay, step 2. When you differentiate y, remember that it's a function and apply the chain rule. So, which means, I guess, remind yourself that when you take the derivative of the part that's y, multiply it with y prime. Next step, you want to isolate y prime. So get y prime on one side of the equation, everything else over to the other side. Solve for y prime. Okay, first example, we're going to let x squared plus y squared equal 4 and find y prime.
So first thing, you would move the x2 to the right side.
First, we're going to do the first step, which is differentiate both sides. This is first, I'm just going to write down what we're looking at. The x squared plus y squared equal to 4. Okay. We're going to take the derivative of both sides, just as it is. So do the derivative. We're taking the derivative with respect to x. Same on the other side, take the derivative with respect to x of 4.
We'll use that sum and difference rule.
Yeah, and actually, before we move on, I'm going to add a little extra here. So this y prime is, we're going to put, it's the derivative of y with respect to x. It's dy dx. So that way, you know, so you take that variable into consideration when you're doing this derivative. So we're gonna, I think it was mentioned, do this first term and use a power rule, bring down 2x, multiply it with x, and it has power 1, so it's a 2x. Okay. This y is a function, so you use the chain rule. We'll start with the derivative of the outer function, which is y. Bring down 2, multiply it with y, which has power 1. And then from the chain rule, you're multiplying by the derivative of y, which is y prime. Okay, equal to 0. Derivative of 4 is going
Wait,
to
how
be.
to get derivative y? How to get derivative y from?
It's from the chain rule because y is actually a function of x. So.
Oh wait, because we're trying to find y, right?
I think I'm going to write this in a little bit different just to help show you what's going on. But then we're going to continue doing this work like this. Okay. And let me put down 0 first. Okay. just, you have y is a function, y equals f of x. So I'm going to let's see, we're going to start here with this notation. So we have x squared add f of x squared, and it's equal to 4. Okay, and then take the derivative of both sides.
Oh, because we're like finding y, so that's why like y equals fx, something like that.
Yeah, y is fx, and yeah. We're trying to find y prime. So let's see, or f prime of x. Oh, no, it's not me. Okay. So for matching, and then we did this step here, which we're going to do on this side as well with this different notation. And start with this first term, you bring down that 2, multiply it with x. The derivative of this part needs a chain rule. You bring down 2, leave the inner function alone, remove 1 from the power. And then you have to multiply by the derivative of the inner function, which is going to be f prime of x. And then on this side, you've got the derivative of 4, which is 0. Okay. You can keep solving this way. We're going to go over here and just solve it that way. They're saying the same thing. Okay. So see, we take the derivative. We remember to multiply by y prime when using the chain rule. We want to, I think, isolate y prime, and then we'll be done. So let's subtract 2x for both sides. Okay. Solving for y prime. So you want to divide both sides by 2y. Okay. So that reduces, what's left is y prime. Over here, there's a negative, those twos reduce to 1, and there's an x over y. Okay, next example. We're going to let. Five x squared plus 3xy minus y cubed, and have it equal to 10. Okay, and find y prime. dy dx. All right, let's start just copying down the equation. Okay. And then I'm going to take the derivative with respect to x of both sides. So on this side, d dx. This side. Okay. We're going to start with the first term, which isn't too bad. So right here, doing this derivative. And you've got this 2 times 5, which gives you 10 times an x. Okay, this part's a little tricky. You've got 3x times y, so you're going to need to use the product rule.
Because y will always equal fx, right?
What did you say?
Y will always equal fx. Oh, y will
Y is f of x?
always equal fx, right?
Yes.
Yes, right?
Yes.
Okay, yeah.
Okay. We're going to call 3x f, and we're going to call y that function g, and use the product rule.
Yeah.
This is f.
Or wait, or like c of x could be g and then y equal f because it makes more sense, you know? That could be.
It's just, I'm just trying to match it with the f prime g plus g prime f.
Yeah.
I mean, I guess we could use different letters.
Right there.
Huh? Okay. So we're going to have the derivative of the first function times the other function, which is going to give you 3 times y. Okay, derivative of this function would be y prime, and then multiply it by the other function, 3x. Okay, then subtract derivative of this last term, which you need to use the chain rule on, subtracting 3y squared times y prime.
Wait, the derivative of fx, the derivative of 3x is just 3.
Yeah.
Wait, how does that work?
So you bring that power 1 down and multiply by 3,
Oh,
and
okay.
x has power 0.
You use the power rule, right?
Yeah.
Yeah, use the power rule, right?
Yes.
Okay.
Okay, so this is all.
But, I have a
Yeah.
yeah. I think the only problem we really have is like which rule do we use, you know? How do we figure that out?
Depends on your function. It depends on what you're looking at. Like, you mean, how do you know that there's like a 1 right here?
Or like how do you know like which one to use? Like because there's like there's like, you know how like in certain cases there's like many ways to get the same answer, you know?
Oh yeah. Well, then there are sometimes different ways to get the same derivative using different rules, as long as you're following the rules. And I think a lot of practice. That's just to know. That's just how it's going to help to know which ones to use. Just practice and like start maybe memorizing these
Okay.
rules. Yeah.
Yeah.
Okay. Is this all equal to 0? Derivative of 10 is 0. All right, let's see. We're trying to isolate y prime. So let's keep terms that have y prime in them on one side of the equation. And then we'll subtract those other terms from both sides. Get them set up like this. Okay, so let's see. On the left side of your equation, we're going to keep the y prime times 3x and then this term here, the negative 3y squared y prime. Okay. And then we're subtracting 10x from both sides, and we're subtracting 3y from both sides. Okay, from the left side of the equation, we're factoring out y prime. Okay, now divide both sides by this 3x minus 3y squared, and that will give you y prime.
Wait, the question to this problem is to find the derivative of y, right?
Yeah,
Okay.
and we found it using implicit differentiation.
Mhm.
Okay, I'm gonna do another example.
Oh yeah, Professor, just to ask you again, the quiz gonna be on all of chapter 3 or just like which part of chapter 3?
For the next test? Or wait, is that oh the
No,
quiz?
for the quiz tomorrow.
Oh yeah,
Yeah.
probably like the 3.1, 3.2, 3.3. That's where I'm gonna look for questions.
Okay.
Yeah, we'll wait
That's all
till
I need to know.
practice the
Thank
chain.
you.
Yeah.
Okay.
Okay, next one. We're going to have 5 with power y. And 3x squared. Is equal to e with the power of sine of y. And we're going to find the derivative of y, or y prime.
What does dy over dx necessarily mean though? Like the derivative of y over x or something?
Yeah, like say it's the derivative of y with respect to x.
Okay, because like like in the last example we did, like both of the equations have like a y in it, and they both have x. So like I think people might get confused on that. So
Yeah, because I mean, because what you could do, I don't think we're going to do it in our class, but you could do the derivative, like let's say, I think if I wrote the x dy, is saying like take the derivative of x with respect to y, and I guess x would need to be a function, some function of in another variable, but then you would take and apply the chain rule to that variable instead, and then leave this one as like a regular variable and use the regular rules on it, no chain rule. So it is important that you do have it dy dx, especially when you've got those variables all sitting in here. It's telling you which of those variables is actually a function, and which of them is just a variable. So this is a dy dx. Okay, let's take the derivative of both sides. Mm. Yeah. Maybe I'll think of some fun examples later on, like if we come back from spring break into examples where we play around with like functions and variables and notation to get used to like the notation. But for now, differentiate with respect to x. 5y, 5 to power y, plus 3x squared. And then the same thing to the other side, derivative with respect to x of e to a sine of y. Okay, for that first term, it has that function y equal to f of x as part of it, so we need the chain rule. So start with the derivative of the outer function. 5 to a power is that same 5 to that power, 5 to power y, times ln of 5. Okay, then you have to multiply by the derivative of the inner function, y prime. Cool. On to the second term. So x is just an x, and you use the power rule. And we've got 6x plus 6x.
wait, when do you use the exponential rule?
We did that one right here with 5,
Yeah.
and as your exponent is your like input from the function.
So like we use the exponential if like the power does not like a number, right?
Yeah, if it's switched around where the base is a number and the power is a variable, or I guess in this case, a function.
Okay. Yes, a function. Okay, yeah. Okay, I got it. So technically, so exponential if the power is like a variable, and we use the power rule if it's like an actual number, right?
Yeah, if there's a number up here and there's a variable right there.
Okay. So I'll make sure. Thank you.
Okay, on the other side. Another chain rule, because you like way in there, is that function y, which is, f of x. Okay, so the derivative of the outer function would be e to its power, e to the sine of x. Let me sketch this. Okay, and then you go in, which in this case is up to the power exponent. Take the derivative of that inner function, which is the derivative of sine. It's going to give you cosine of y. Sine of y, and the cosine of y. Okay, and then y is a function, so you go even further in with the chain rule and multiply by the derivative of the inner function, which is y prime. Okay, now I just use some algebra to solve for y prime. So let's get them both on the same side of the equation by, I think, subtracting we're going to subtract the e to the sine of x cosine of y prime from both sides. Now that's going to make us move stuff around a lot. Okay, let's subtract this 5y ln of 5y prime from both sides, and I'll get them both together. Yeah, that's fine. Okay, we're at 6x equal to.
I'm also by the way, so like wait, just a reminder. Wait, sine you got cos y from sine, right?
Yeah, that makes sure. Yeah.
Good, just want to make sure. Thank you.
Yeah. We're running out of time. Okay, let's just finish this one and then we're gonna go. Sorry to keep you a minute or two over. And let's see, when I did this, I subtracted the 6x and then I minus this e to the x. We're gonna get the same answer anyway. Okay, let's do this. We've got 6x equal to this minus this. E to the sine of y, cosine of y prime. Minus a 5y ln of 5y prime. Okay. Factor out y prime and then divide both sides by that other factor. And then we're going to have the answer, which I'm just going to jump to. Okay, so we factored out the y prime, and then we're going to have the 6x divided by what's left. Which would be e to the sine of y, cosine of y. Minus 5y ln of 5. All right, I think we're going to keep on working on this section for another page or two when we meet tomorrow. Thank you, everybody. We're done for today.